I would like to ask you 3 questions. Actually, you can see them on the on the mobile, because we are discussing about where we can find data, which is the first source for looking for data. So it's quite interesting to see which, we as user of all this data, which is the first place where we go when we need to do any kind of assessment or any kind of analysis. The other one is very related to this one, because it's also related to the kind of interaction and services that you would like to do on that. And the third one is more technical, I would say, because the first level, of course, is doing an asset mapping. But then we need also to consume this data. So it's more to understand which is the level of, let's say, which tool is the preferred one to be used when you consume this data. So I'll give you a couple of minutes while I'm also switching to the. Oh, guys, come on. It's only 7 answers. Fill up it. We are about 50 people. So. And that is interesting because then it's also important, because when we do any kind of gap analysis, we may have an entry point to see if we are really considering all the data that we may have. And somehow, as expected, the 2 ones that are popping up are Immonet and Copernicus Marine, I guess in situ, because we're speaking about in situ data. Let's also look at what is happening in the next one. This is also interesting. Because when we, again, this is quite important, for example, for people that are designing, let's say, the interface in order to offer the experience to look for data, which is the entry point. So when you look for data, which is the feature, call it like that, that you're looking at mainly. So here we see that, for example, most of us are looking for intervals, I guess. So data in a given period. So this is something that is very interesting. Okay. And of course, the answers will be part of the report. So the last one is this one. Okay. And this is also very interesting because this facilitates somehow also, some of the presentation, because later Beatrice will show you how to play with some of the tools that we implemented in task 2.4. Okay, so I'll leave you this one to keep going if you like, and then we'll go back to this. It's like that. Okay. So we are speaking about in situ observation observing program. So when we speak about in situ observation, we have already mentioned that. I like this picture quite a lot, so that's why I'm putting it together. But it gives a very nice representation of which are the sources, the platforms that usually are producing data and we can consume and use in all the kind of analysis that we were discussing for the past 2 days. I also try to make a sort of a very brief overview of what was happening in the past years that somehow is was shaping the situation and the framework, on top of which we now have some programs and tools that we can use to find data and consume the data. So if we start speaking about International Oceanographic Commission in the 1960s, Then we have the IOD soon after. Then we have the implementation of the GOOS that somehow started shaping a better global approach to the observation. In 1995, we have the Regional Alliance that were also moving the focus to the regional application, let's say. And more or less in the same time, we had the European Commission that set the route for for two of the main projects. At that time, they were projects that were shaping the data interoperability and data collection and data sharing at the European level. That are SIDATanet, and at that time it was GMAP, but it was MyOcean, and now it's Copernicus Marine Service. So we have already mentioned it several times. In 2001, GOOS established the Integrated Global Observing System, and a couple of years later, we have the starting of international programs like Argo that did really a change of the way we can access the data, because since then we have quite a lot of in situ data, especially in open water. Then in 2006 we have the formal proposition of the EMONET, that is the European Marine Observation Data Network, and then from 2006 up to now we see that both EMONET, MyOcean, Copernicus were evolving to become operational system at the European level to facilitate the data sharing and implement observations and modeling capacities. And a couple of years ago, we had two main milestones also for these two programs, because Copernicus became the Copernicus Marine Service that is fully operational, and we had also the centralization and repatriation of EMONET. That means that now it is under it's an official European program under the European domain. That makes some important consideration. So this is also to remind some of the key framework that are behind all these, organization, because in the end, both the International Geographic Data Information Exchange and GOOS on the other side were facilitating a framework to discovery and exchange the data. And both initiatives were looking at developing a framework in which people, nation, up to experts, could implement long-term collection and preservation of the data. And when we do this, we have always to think about also the complementary documentation that should be attached back to the data. Otherwise, we cannot do many of the things that we were discussing just a couple of minutes ago. What is also important is also remembering that, for example, from the International Geographic IOD, we have some specific definition of key entities that are dealing with data, because we have the National Geographic Data Centers that are officially designed by the IOC member states, and they are, they have the capacity, or they are designed to provide access and stewardship of the national resources. But in parallel, you may also have some associated data unit or associated data information unit that can support and provide complementary facilities in order to implement data management and data sharing. And this is also nice because this is coming from one report. It's a bit dated because it's an overview of the data that was collected between 2017 and 2019. But somehow it's also giving a picture of how many entities are dealing with the data. So when we think about this overarching, how do you say it? Okay, collecting infrastructure, integrating infrastructure, we need to think about that they should deal and interact with these nodes, because they are the ones that are really carrying and storing the data. And this is also nice to see which is the level of data exchange that we have at international level, because this was already mentioned in the previous presentation. We have that at national, you have some national focuses Some of these national focuses are also related to the regional area in which, of course, that member state is located, and they are also supporting some international collaboration. But you see that, I mean, it's nice. We say the IoT, we say Goose. I mean, Sabrina already presented it widely, so I don't spend that much time on that. This is also important. We already mentioned that, but it's important to remember that thanks to the Goose, thanks to the identification of observing networks, we have some specific routes, and we have, I mean, different member states that are participating to this, and we have also the possibility to access to a huge amount of data that is collected by these international programs. Goose also defined the essential ocean variables. Yesterday, Toaster already presented this. It's quite important because, again, we are now moving towards this concept, and so from that we go to this. But what is also interesting, I found this. I wasn't able to find the interactive one, but this is nice because when we speak about EOVs, we are speaking about something that is more than the parameters, and each single parameters might contribute to different EOVs. Each single parameters may be collected by more than one platform, and so this is a nice way to to see this concept, but it's also impacting the way we need to look at the data or organize the data or harvest the data when we do the analysis that we were discussing in the scientific talks of this morning. So how about the national contribution? Some of us have already been touched by Johannes. This is an example that I copied from JP Ocean, and it's nice because it's, very similar in all the member states. We have the case of Greece, so we have also some Greek colleagues, they can confirm that. We have different ministries that are usually allocating the funding for serving some specific national purposes. And then we have some institutes or or entities that are receiving these funds in order to implement the programs. And they may be both academic institutes, but they could also be some government one. In fact, in most of the countries, the meteorological services, the Navy, the Coast Guard, and others are really involved in this process. And time by time, we are not receiving this data. This is also part of the discussion that we need to have. And on top of that, or in parallel of that, you also have, of course, the research activities. So you have the university, you have the foundation, and so on. And all this data is, of course, collected, organized according to the rules that are required by the ministry of the entity that is doing the job, down to some level of integration of sharing. So in case of, let's say, the ocean data that is coming from public, let's say, funds, and this collected by research or private entities that are usually feeding the National Geographic Database, and from that one, it's supporting international programs, and you may find this data also in the international, European and international marine data integrators, SIDATANET, IMONET, and so on. So we said key European integrators. Which are the key European integrators? We know, we already mentioned the Copernicus Marine Service in situ TAC, because we are speaking about in situ TAC, and IMONET on the other side. This is the workflow, how the in situ TAC is working. What is important to say that, of course, they are integrating many sources. They are integrating member state data sources from the different National Geographic Data Center by means of the regional thematic assembly data center, but they are also integrating some international data. This is the list of the ones. And on top of this, Copernicus is also applying some common procedures in order to qualify the data. This data is all public available. IMONET, and in particular IMONET Physics, is one of the 7 pillars of IMONET. Here we have a very nice infographic that is showing the ecosystem around IMONET because it's dealing with many disciplines. IMONET is designed from the Commission to be the in situ house, the house for the in situ data. And so, especially for ocean physics and operational biogeochemistry, the activity of immanent physics and Copernicus in situ Turkey is very close, and we are doing everything together because, of course, the interest is to make as much data available as possible and to offer the stakeholders the best quality possible. That doesn't mean that it is exactly the same data, but I mean the best, according to the kind of application that you want. Physics is building on top of marine data infrastructure, and in fact is also receiving the data from Copernicus. It's fair from standard tools and blah, blah, blah. And of course, it's covering mainly the ocean physics. That is part of the discussion. I mean, it's quite interesting for all the discussion that we are having in ObsSea4Clim. Then, if you are, let's say, a dummy user like I can be, usually you go to the website, so the GeoViewer, and what the system is offering is, I mean, an interface in which you can select a theme. So you go under physics, then you can play with the topics. So the themes you can select by parameters, so you can go to the in situ data. Then you load the layers, and then if you interact with the layers, the stations, then you can access to information and data that has been provided by that station. So you have some basic metadata that we need to clean up, and ObsSea4Clim is also supporting the, let's say, reasoning behind how to improve the quality and the quantity of metadata that can be already presented on at this level to general stakeholders. And of course, you may see a preview of the data that has been collected, and you can download it some formats. And in case of physics, sorry, this is out of the slide, we are already integrating this data, these data sources that, as you can remember, they are slightly different from the Copernicus, because one main difference is that the given the fact that IMONET is designed by the Commission to be the house for in situ data, we have more flexibility in order to ingest and make visible more data as soon as possible. So we are not required to apply the same procedure to qualify the data as far as the data is already qualified. So if we are connecting a source that are already providing qualified data, that is already fine for IMONET. In case of Copernicus in situ, as the package should serve a specific community, that is the forecasting community, the harmonization of the procedure in order to qualify the data should be the same for all the data. So not all the data can go through this process. And so somehow the Copernicus in situ is a sort of subset of immanent physics, but we are working together, as I said, in order to have this gap as small as possible. How many data, which quantity? Because we were speaking about, I mean, problems that we need to access the data. So if we look at some reports, for example, the LSE Global Science Report, we see that this is the number of research vessels in different countries. So there are many. And they are operating a lot of days at sea. So we suppose we expect that there are a lot of data. If we look at the World Ocean Database, again, we see a very nice picture of data that is flowing into the system. This is also interesting to keep in mind, because most of the data are surface data, I would say. So only lately, we are starting collecting data in the, let's say, it's not deep ocean, but at least it's not surface ocean. And this is also important because if we are thinking about application that needs data that are a bit below the surface, we may not find that much. We say IMONET is the house for the in situ data, so we guess that all this data is already available, is connected to that. And so on top of that, we can start doing some action. So we can try and see if we have complete metadata, if ocean best practices are mentioned, and so on. And so, in theory, we can also do the exercise in order to define or verify the accuracy or uncertainty of the data. Physics is organizing the data in three different levels. We have in situ data that are series of values, profiles, time series from a given platform, or data collection. That is packages that is grouping similar data. For example, the CTDs are a package, sea level with the same frequency, surface currents from a given platform, for example, for the HF radar, and so on. Of course, in physics, we are adopting, as already mentioned, the standard open data. So the data that is available in physics is open and free, CC BY. And then we are doing, of course, some harmonization of the vocabularies and the metadata that we are offering. Of course, this is needed also for offering the user experience and having the opportunity, the possibility of having drop-down menus or filters and so on. This is the amount of platforms that you find in physics, in an object in general. So you have, it's quite good coverage. But it's less than we were guessing. This is also important to mention that the level of hierarchy to organize the data is constructed in a way that you have, let's say, a level, a concept ID, a concept that is describing the phenomena, for example, temperature. And then in order to really access the data, you need to somehow refine this concept, because the temperature may be collected as a time series. So you have platforms that are collecting time series, and this is a package, or profiles, that is another package. And then you have different tools that may collect the things. And so we are adopting these standards. This is also important because everything is related and is probably metadata. So now that we have this framework, it's clear that we are expecting that all this data is going into IMONET. We can start doing maps on data, so we can do some assessment of the in situ gaps. So the exercise that we did in order to implement the data density map, we started, of course, from IMONET. So we defined as, let's say, binning condition to have monthly maps and with a grid resolution of 1 degree per 1 degree. We tried to use, let's say, the collection, the top-level collection of IMONET, but it actually was not possible to use that one because as in at the top level, we are only storing the information about when there is the first observation and when we have the last observation. We don't catch at that level if we have gaps in between. In order to make a gap analysis, we need to really see when, exactly in which specific case. Then, of course, we squeeze it a bit at the monthly resolution. We have really data for a given parameter. And then we needed somehow to reorganize also the thinking around that because we were not able to use the collection that are already available in physics because they are huge and so they are not easy to handle. So eventually we had to go platform by platform, parameter by parameter. This is to say. And it took a while, 3 weeks in order to extract the data. But I mean, the number of platforms and data that we were using for implementing these maps are not good, but they are not bad. We developed a specific dataset with the result of this, and now this is part of the products that we are releasing as ObsSea4Clim, so it's already a product. We are also updating. Beatrice later will show you more about that. And there is also this, let's say, constraint that we applied that when we put to as we processed it one platform by platform. So it means that we made maps for each single platform, so we know which grid cell or which area the platform was covering when, and then we submit somehow all these maps. And when we are making the density map, of course, if we have at least one platform that collected data in that given month, in that given grid cell, we skip the rest. So we may have more recordings for that specific grid cell in a given amount because more platforms can be in the same area. But at least we have the idea that we have one sample there. And this is somehow the outcome of the analysis that we did. So back to the dataset that we developed, we also developed a a Python Jupyter notebook in order to explore and play with the tools. And this is an example of what you can get. So the color is indicating the number of days with recordings in that given grid cell. So for example, here we are looking at data. So the map is showing data from June 2024 to November 2024. So we have 5 months of data. 5 by 30 is 150. So 175 is. If we are around the red, it means that we have a pixel that is covered on a daily basis. If we are around green or yellowish, it's 1/3 in that period. It means that you only have one data every day, 3 days, or 1 month every 3. And this is already a nice result because you can also see which is the coverage in time for decades. For example, in this picture is showing which is the amount of data that we have between 1980s and 1st January 1980s to 1st January 1990. If we go to the next decade, we see more data, but they are not that many because we are always around the greenish stuff. So it means 1/3. 1/3 means that you have one recording every 3 days. And we have a lot of holes. Then, of course, if we go around 2000, when the Argo and other international programs are started sharing data, we see a better coverage. And this is the last 15 years. So in the last 15 years, of course, yes, it's last 15 years, we see that coverage is much better. But again, we see that they are always around here. So each grid cell has only one data, let's say every 3 days or every 4 days. And this is just to show you an animation about what is happening in the net. And now the situation is changing month by month. But what else you can do that with that? I'm closing. If you have this density map, we were discussing about heat waves. So if we have heat maps, we can say, okay, we know that here we had 8 heat waves. This is the amount of data that we have. Can we really approach that? We are missing something. So that is a good starting point. It's not, I don't know if it is good starting point, it's a starting point. Why? If we consider another area, maybe the situation is better. So we can have better understanding of what we're doing. As said, we also released the second version, but I don't spoil that much. If you want to play with the downside, is that one, and I give the floor to Beatrice because we have an hands-on session, so we also do things, and she is going to present the tools.
Yeah, I don't know how much time we have. Okay.
We'll go 5 minutes until break, but we started.
Okay. So, hello everyone. I'm Beatrice Scotto. I work for HT. And here you have the QR code to scan and to use the first version of the collab that we have released along with the deliverable. It won't be really enjoyable on your phone, but you can play after also on the computer because it's going to be like a bit better. I need to. Okay. I will show you quickly the first version of the map, of our map that Antonio presented. And here basically what you have is like the main point, that entrance point at of the tool. And my suggestion is before all you go on runtime and run all the cells. You can also run the cells by clicking all the play points here when there's like show code. You can also watch the code, like open the code and so on, but you don't need that for now. And yeah, so by running all the cells before, you don't lose like some points that are essential to have like then the map. In this first version, you have 3 data sets. that we have created. One is for the currents, one is for the salinity, and one is for the temperature. All of these are available for the worldwide, but you can also select, for example, an area going like with the slides and so on. So you can select, for example, here and do whatever. You can also select a start month and a end month on your analysis. In this, you will have all the data until 2024, and also you can select, of course, the depth. And the depth is sliced in different bins. So by the bin that you're choosing, you're having all the platform that goes from the top to that levels, from the minimum depth and to the maximum that you have selected. And then you have the map that shows you, this is like the number of days of not service, because it's like from all of that, of currents, and gives you also like the color. You can also select, that was pointed out by one of the partner, you can also select different colors. For example, if someone has like some trouble, of course, and that was a really good feedback. We always need feedback, so please play around with these maps. And now I will show you the second version briefly, which is as basically the same structure. You go again on runtime, run all before, and then here we just have some test data sets that are not released. We are working on it, but right now we have some months for temperature and for some months for salinity. Also here you can like select your area, the months, the start month and the end, and what we have here really going through is like you can select smaller slice of your of the data set. So, for example, 0.1 degree of latitude to read the resolution. Also, again, the color bar, the depth, of course, and so you have the first map, which is basically the same as before, but we also added some more detailed filters. For example, here you can select for run, so otherwise I will not be able to show you. You can select, for example, for the source. Now you will see that we have just two sources showing, and we will add more. Like for example, when you see like the other, now it's not collaborating. When you see the other, it's going to be, for example, MEOP data or ISSCTD or other platform or other sources. Also, sorry, it's not working. You can perform a selection for example, the quality check variables, and for example, we want to see the stack Copernicus Marine with the best data that they have, and you can also perform a selection from the P01, which gives you more in-depth information about the parameter that you're selecting. And so, for example, water temperature, and then you run again your code, and you will have a map that will be a little bit different because now you have performed some filters, and so it should have more or less, I don't know if all the data are good, but yeah, we will have less. Okay. And yeah. Here we all the filters for one source, one pussy code, and one parameter P01. And yeah, that's it. Again, like we have to move on to the
wrap up in 3 minutes.
Yes. Okay. Okay, so starting with that, then we can start moving towards uncertainty map. As we said, the new version will include more metadata, basically, and there is also an idea that we start thinking about also including some information about sensor and of course linked to best practice in order to be able to have more filters to be used in order to refine the selection. Then I will also want to mention this exercise that has been done by and others that somehow could be also a starting point with the maps, with the density map, and with this, let's say, table of uncertainty that has been extracted for the different platforms, we can play and try to have something that is closer to uncertainty maps. How to improve? Of course, we need to work on the data management because there are now some recommendations because we were able to give numbers or objectifize them. We need to work on best practices. We need to keep working on gap analysis. We need to support data integrators to fill gaps. We can also think about the activities that we are doing again in the task 2.3 tomorrow. Tanya will present on that. And then there is also somehow an internal call to action because this is something that we can do as a clustering opportunity to write down a sort of white paper or recommendation that can be applied not only on physics. 2 minutes, because this is important. Data management plan. You are all committed to this one. We are a European Horizon project, so we have some mandatory things to do because we need to include the data management plan. It's a dynamic documentation that is continuously updated. We have rigorous, constraints in order to be fair. So everything that we are producing should be that. For us that are ocean-related project, of course, we need to think about some stakeholders that are immunothermics and so on. This is what you already should know, because it's already written in the document. We are already working on the version 2. Here you have the code in order to read that one. As I said, we are all committed to data management plan. So please, if you find something that you are not confident with that, let us know, because we can improve. We have to work together in order to capture the latest version of the data management in our project. Of course, 5 principles, you know that. This is also important to keep in mind because CORDIS, that is in a European Commission tools, access comprehensive information, is providing a comprehensive information about all the project. We have a page on CORDIS. This is the link to the page. So ObsSea also has a UI and should be used in order to avoid funding that we are receiving. CORDIS is federating information from OpenAir. So you know that Zenodo is an OpenAir. We are using Zenodo in order to publish all the public deliverables and documentation that we are doing. And it is important because it's automatically harvested by CORDIS, and it is used as one of the indicators, a KPI, that the Commission is using to evaluate our project. So this is important to know. This is 2 slides really to remember you how to do that. So if you need to update a new document or a new deliverable, you go there. You go to the community of ObsSea4Clim under Zenodo, you do your upload, then you have your interface. It's very straightforward. This is a very important. If you have a DOI for any given documentation, you have to put it there. This is the most important part because we need to write this part in the grant agreement because this is the field that is harvested by CORDIS. So please remember to do that, search for it, apply, and then you get it. Then app. So 4 or 5 clicks, and then you get it. And this is fundamental. So if you don't want Chiara to get angry with you, do this. And by the way, we also opened the GitHub. So for the ones that want to be included in that, because the code or the dataset that we are releasing, they are also going to be available there, please let us. So we put, it's just opened, we opened it today. And please do not forget to help us in filling the inventory of the data. Because as we said, we need to fill gaps and we need to know where the data is again. Okay, this is the plan, and thank you very much.